Hi and welcome to the video on significant figures. This is just a brief tutorial quickly going over the concepts and rules of significant figures. So first off, what are significant figures? Essentially, they are the numbers in a measurement or calculation that count in terms of precision. So let's say, for example, we have this red line and we want to measure it. We want to measure its length. What would we do? We would take a ruler, and since this is science class, we would use centimeters. Um, and as you see here, the line falls somewhere between the 3.8 and the 3.9 mark on the centimeter ruler. If we blow that up a bit, we can estimate with our eye that it's about maybe like 3.82, I would say. And the way that we do that is we divide this space up in our mind by 10, which is how we normally count. And I would say that looks like it's uh, closer to the 2 than any other number. So this last digit here, the 2 that I estimated, we would call that the uncertain digit because we estimated. And in every significant figure, the last digit is always uncertain. So what do significant figures have to do with precision? We talk about its significant figures being a number in a measurement or calculation that count in terms of precision, like the numbers that matter. So to see what I mean by that, if we're measuring this line, this red line again, but instead of having this really nice fancy ruler with all these increments, let's say we have this ruler that only has increments for the centimeter marks. In this case, again, I would do the same thing when I'm measuring it. I would look and I would see, oh, it's between 3 and 4 centimeters. But now, since I don't have those millimeter markings to help guide me, in this case, I would have to estimate, and I look at this and I say, well, this is like the halfway mark here, and it kind of looks like a 0.7, so I would probably estimate that to like 3.7. And between the two measurements, the one where I'm using the millimeter markings, that is more precise. It's a more precise measurement than in the case when I'm just using the centimeter marking ruler. And you notice in this case with the centimeter marking, my uncertain digit is that 7. This is the one that I estimated. So big picture ideas, significant figures are the numbers in a measurement calculation that count in terms of precision. And when we're talking about precision, the farther to the right of the decimal the uncertain digit is, the more precise the measurement. So if I go back real quickly, that in this first measurement, the number, this measurement is more precise, 3.82, because the uncertain digit is further to the right of where the decimal is. And here, in this case, it's less precise, this measurement is less precise because it's not far to the right. It just has to do with the placement. So here the uncertain digit is in the 100th place, and here it's in the 10th place. All right, so why are they important to scientists? In addition to showing how precise the measurement is, like we're looking at this number 3.7, that's not so precise. We could make that more precise if we use a better instrument. So that's one thing it tells you is the precision of the measurement. But it also is really helpful when you're doing a calculation and you want to know where to cut the numbers off. So if you get some number like this and you're like, oh, should I use all these digits? I don't know. And that's where significant figures are really helpful. So in understanding that, there are a couple of rules that we have to go over. The main rules are how to count significant figures and then what to do when performing calculations with significant figures. And we're going to focus really on addition and subtraction and multiplication and division because those are the types of calculations we do in chemistry. So let's start off with rules for counting significant figures. The main thing is you want to count all numbers as significant numbers except for the zeros. So sometimes zeros are significant and sometimes they are not. And so here are the cases where they are significant. If you have a zero that's found between non-zero digits, like This 0 here is found between like 82 and the 24 on that side, and so this 0 would be significant. And so now we can count all of these numbers, 1, 2, 3, 4, 5, and we have 5 significant figures here. I'm just counting each number. Another case where zeros are significant if it comes after a non-zero digit and a decimal is present. So here, if you're looking at this number here, 83,000, there's a decimal there. So because of the decimal present, we're going to count all of these as significant. So 1, 2, 3, 4, 5. There are 5 digits, 5 sig figs. Here are the cases where they're not significant. If you have zeros that come before a non-zero digit, whether there's a decimal place there or not, but usually that means that there is a decimal place there. We won't count these zeros when we're counting, so we will not go like 1, 2, 3, etc. We'll start counting as soon as we see our first non-zero digit, which starts at the 4. So there's 1, 2, 3 digits there that are significant. These zeros are not. And finally, a case where the zeros come after our non-zero digits, so our zeros are after the 8 and the 3, and there's no decimal place present. So in this case, we will not count those, and we just count these as 1 and 2. And this says 5, but that should say 2 significant figures. Sorry for the copy and paste error. So again, in this last one, this is 2 significant figures, not 5. All right. Really quick way of memorizing this. I actually don't usually go for tricks because, as I said, tricks are for kids. But in this case, this is a really cool way of memorizing what to do when counting significant figures, is by memorizing a map of the US. So if you know the US, the Pacific is on the west coast. So here you'll find the Pacific Ocean, and then on the east coast you would find the Atlantic Ocean. And the rule is simple. If you have a decimal place present, so notice the P, you count your first non-zero digit starting from the Pacific side to the Atlantic. So we would count from left to right. So what do I mean by that? I look at this number here, 83,000 is a decimal place there. Even though it's at the end, it doesn't matter whether it's in the end or in the middle. And so in that case, I'm going to start from the Pacific side, so on the left side, and count all of the digits over. So 1, 2, 3, 4, and 5. And then in this second case, again, we have a decimal place in this number. And so again, I'm going to start from the Pacific side, but I need to always start counting from the first non-zero digit. So these numbers that I see first are all zeros. I'm not going to count those, but I'm going to count starting at the 4, and then I'm counting again from Pacific to Atlantic. So 1, 2, 3. In the case where there's no decimal place, so the decimal place is absent, we count from the Atlantic to the Pacific. So notice the A's and the A's. And so in this case, I'm looking at this number. There's no decimal place here in this first number, 82,024. And so I'm going to count starting over from the Atlantic or the right side. And the first digit is non-zero, so I can start there. 1, 2, 3, 4, 5. And we're going to do the same thing with the last number. Again, I notice this error here, but we'll see it when we count. So no decimal place. First digits that I see are all zeros, so I'm going to skip those, go straight to the 3, and start counting over from, again, the Atlantic to the Pacific. So 1, 2. So this, again, should be 2 significant figures. Sorry again for that error. Okay. Next steps. At this point, you may be thinking, hey, I want to see more. I feel like I need to watch this again. You can watch the significant figures and zeros video. That's the 1.3 video. If you're ready for practice, then watch the significant practice problems video. As you're watching the video, make sure you pause it so you can try the problems on your own. All right, we went over counting. Last, we're going to go over performing calculations, starting with just going over the basic rules. So when you're doing adding and subtracting, you're going to report your answer in the least number of decimal places, and we'll see an example of what that looks like. Multiplication and division is different. You report it in the least number of significant figures. So let's take a look at some examples here. In this first example for addition, we have 13.0198 plus 1.2. If you look at the two numbers that we're adding, the top number has the most number of decimal places, so 1, 2, 3, 4 numbers past the decimal, and the bottom number only has one decimal place. So when we report our answer, we're going to use the least number of decimal places, so that we're just going to report our answer to one decimal place. So if you look at our sum here, we don't need the 1, 9, and the 8 because we're just using one decimal place, and our final number is 14.2. Again, it should match the least number of decimal places. For multiplication and division, it's least number of significant figures. So to do that, if we look at the first example of multiplication, I notice I have 3 sig figs here, and then here, how many do you think you have? Notice there's no decimal place. Yep, you should get 2 sig figs for the second one. So between these two numbers, this second number has the least number of significant figures. And so our answer should be in 2 significant figures. Now here's our answer. This is the complete product. But we're going to cut it down to just 2 sig figs because that's how we need to report our answer. And so now our final answer is 9,800,000. Notice that all of these non-zero digits we just replace with zeros to get it to be 2 significant figures. Okay, in this last example, we're doing the same thing except for it's a division problem. This is a decimal place in case you didn't notice. So when we're counting from Pacific to Atlantic, and there's 1, 2, 3, 4 sig figs here. And in the second value, we have 3 sig figs. So how many significant figures should our answer be in? Has to be in the least amount, that's right. And again, it just so happens that's the second number. But it's 3 sig figs. So when we go to report our answer, we are reporting it in 3 significant figures. That means I want to cut it off here, because remember, we don't include these first zeros. So I want to cut it off here. And again, this last zero is significant because it's after the decimal place. And we've already counted some non-zero digits. All right, so final note here, when adding and subtracting or multiplying and dividing, you always want to make sure you round appropriately. You want to do that at the end. So a lot of times I just worry about my significant figures at the end of my calculations. I don't worry about it in between if you have to do multiple calculations. And what I mean by round appropriately, remember wherever you're cutting off your number, so like in this case we're cutting it off between the 0 and the 3, you always look to the number to the right of it. If that number is 5 or greater, make sure you round that number where you cut it off up, right? So if this number was, if this was 0.01508 instead of a 3 here, we had an 8, we would then make our final answer 0.0151. We would round that 0 up to a 1 because there was an 8 to the right of it. Okay, next steps. If you want to see more about addition and subtraction, watch the add and subtract with sig figs video, that's 1.6. More about multiplication and division, watch the video on 1.5. When you feel ready, take the significant figure exit ticket that will go through the concepts and also the rules. In the future, just know that all of your calculations must be reported in the proper number of significant figures. So we're going over this now so that you feel confident and ready when performing future calculations. I hope you found this video helpful. Have a great day.